everyone! So, in today's lecture video, I am going to share with you on the concept of equilibrium and how we are going to apply it on a 2D coplanar systems as well as in a 3D force systems. Okay, so stay tuned. Equilibrium is a state when a body or a particle is at rest. It doesn't move, so its velocity would be zero. For a moving particle, then we could also consider it to be in equilibrium state if and only if it have a constant velocity. So when an object moves at a constant velocity, its acceleration would be zero. Here are some examples around you that you can observe to be in an equilibrium state. Like this transmission tower. You can see this tower all over Malaysia lah, tak jauh pun. So, can you see this tower running around, lompat-lompat sana sini, main-main keliling padang? No kan? This tower is basically at rest. So, structurally, it is in an equilibrium state. How about these cats playing seesaw? At this state, dia goyang-goyang tu, they are not balanced. So, they are not in equilibrium yet. But in a balanced state like this, then we would consider it to be in equilibrium. Another example is a moving car at a constant speed. It is said to be in equilibrium if and only if it doesn't accelerate or decelerate. If it maintains the speed all the way throughout the highway. If we recall from our previous lecture, a particle or a body or any object, it may be subjected to many external forces. The material of the body in response will also generate a reactive force to resist the deformation caused by the external force. So, in compliance to the first Newton's law, an object can be in an equilibrium state if and only if the summation of forces acting on the body sums up to zero. For the case of a moving body, then it need to comply to the Newton's second law pula, which stated that the object will move in the direction of the force being subjected to it. So if you apply a force forward, the object will also move forward. If you apply the force backward, the object will also move backward. Depending on the situation, it will accelerate or decelerate and follow the equation of F equals to ma. However, in equilibrium state, summation of force should be equivalent to zero. Ingat balik the previous slide. So, based on this formula, ma should be equal to zero. So, remember, in an equilibrium state, although the object is moving at constant velocity, it means that it is in equilibrium state. So, constant velocity means that there is no acceleration. So, in this formula, the A would be zero. The free body diagram, or FBD, is a very useful technique in engineering mechanics where we analyze all the forces acting on the body by drawing the appropriate force diagram. The term free in the free body diagram bukan maksud percuma ya, but it simply means a specific joints or specific components of the particle is being made independent so that it is easier for us to perform the statics analysis. Before we proceed further on drawing the free body diagram, here are some common types of forces commonly used in the free body diagram. I'm going to illustrate the type of forces with this figure, a boy pulling a box with the help of the string. Okay, the first type of force is caused by gravity, or we commonly refer it as the weight of an object. The direction of the force will usually point downwards. The second type of force is a normal force. So it is a kind of reactive force acting perpendicular or 90 degree to a surface. The third type of force is the tension force. Usually you can find tension force for objects involving strings or ropes or cables. And finally, the fourth type of force is a friction between two objects. In reality, there are many different types of force exist, but these are just some of the common ones that you can see in most systems. In order for you to construct a fully functional free body diagram, you have to follow these systematic steps. Okay, the first step is draw the outline shape. The shape represents the components of the object that you want to study. So you have to make sure each component should be made independent ataupun kita jadikan dia free so that it is easier for you to perform your calculations. Nanti kita tengok example macam mana nak buat ni. And then the second step is to draw all the forces subjected to the shape, whether it is an active force ke, whether it is an external force ke, or whether it is a reactive force or internal force. Okay, and then all the directions of the forces and magnitude should be identified and labeled accordingly. Okay, now let's look at this example. In this example, you are given a system with so many different configurations and you are required to draw the free body diagram. So if you notice, in this figure, you have a spring, you have a pulley, and then you have a hook, and then you have a sphere, like a bowling ball over there. So there are so many things going on, and how do you draw the free body diagram of a combination consisting of so many components? So what you need to do is read the question carefully. So they only ask you to draw the free body diagram of the sphere, the chord CE, and the knot at C. So although you can draw many more free body diagram, but the question only asks you to draw the free body diagram at 3 regions only, which is the sphere, the chord, and also the knot at C. Okay, now let us first jot down all the important information given in the question. So already given that the mass of sphere is 6 kg and you are requested to draw the free body diagram of 3 items, which is the sphere, the chord CE, and also the knot CE. So 3 benda je dia minta, you don't have to consider the spring ke, the pulley ke, the hook ke, tak payah tengok. 3 benda ni je you buat analysis. Okay, the first entity that we want to study is the sphere. Okay, now you imagine like you free up that sphere element only. Okay, keluarkan dia from the entire system so that you can only see the sphere and maybe some small portion of cable CE. Okay, now this sphere, dia ada berat kan? So if you remember, one of the common forces used in free body diagram is weight caused by the gravity. So we know that the formula for weight is equals to mg, and given that the mass of the sphere is 6 kg, so the value of g is a standard value of 9.81 meter per second squared. So if you use your calculator, you will get a corresponding value of weight to be 58.86 Newton. Okay, so that is the first force on the sphere. Okay, now look very carefully. What is the item attached to the sphere? Is the chord CE, kan? There's a cable over there. So when there is a cable over there, imagine macam you potong sikit dekat cable tu, then there is a tension force acting on that cable, and we are going to call this tension force as FCE. So there are 2 kinds of force acting on the sphere, which is the weight of the sphere as well as the tension force of cable CE. So cable CE, the value is unknown, but you can actually calculate it using the equilibrium equation. So remember, in equilibrium, summation of all forces should be equivalent to 0. Okay, so now tengok direction of the weight and the tension force. It only happened along the y-axis sahaja kan? So assuming that upward position to be positive, then if the system is in an equilibrium condition, then the summation of all the forces in the y direction should be equivalent to 0. Okay, so now tengok, the first type of force is the weight, but it is pointed downward. So it becomes negative W because it's pointed downwards. And then the second type of force acting on the sphere is the tension force, but it is pointed upward. So you put positive FCE over there in the equation. And this summation ada lagi tak? Tak ada lagi kan arrow-arrow tu? So this summation should be equivalent to 0. If you substitute the weight to be 58.86 Newton, can you calculate the tension force at cable CE? Yes, of course. You just rearrange the equation and you can get the tension force of cable CE to be equivalent to 58.86 Newton. The value is positive. So in this case, this value represents the tension force of FCE, and because it is positive, it is pointed upward because we assume the upward direction to be positive. Now that is done, jom kita buat free body diagram of chord CE pula. Okay, remember the first step, draw the system. The system that we are studying is the cable CE. So you imagine macam you potong a small portion of the cable and you extract dia, keluarkan dia. What's left is, you know, there is a tension force from point C to point E. So kita panggil dia FCE. There's also a tension force from point E to point C. So we are going to call it FEC. From our previous calculation, we know that the value of our tension force is 58.86 Newton. Then we apply the equilibrium condition, sama macam sebelum ni. So the direction of the force are only active in the y direction kan, so kita analyze in the y axis only. So assuming the upward direction to be positive, summation of Fy should be equivalent to 0. So negative FCE plus FEC should be equivalent to 0. So you substitute all the information and you will get the corresponding force from point E to point C to be equals to 58.86 Newton. So kalau dia positif, maksudnya direction yang you assume ni betul, which is the upward direction. Now let us draw the free body diagram of knot C pula. So sama, the first step is you draw the system, which is knot C. So imagine macam you potong the knot exactly at the C point. The C knot is connected to three things, which is cable CB, cable CD connecting to the spring, and also cable CE. So there are three forces acting at knot C. Okay, so from our previous calculation, we know that the force along the CE chord is 58.86 Newton. So we put that value in our free body diagram over here. So if you notice, there are two unknowns, which is the FCD, kita tak tahu berapa, the FCB pun kita tak tahu berapa. But can we calculate it? Yeah, let's try to analyze this kind of situation using the equilibrium equation. Okay, now tengok carefully. FCE okay, it's in y-axis, no problem. FCD pun okay, it's in x-axis, no problem. FCB ni dia dok menyengit macam tu. So how are you going to solve for this kind of problem? So you need to resolve this FCB into two direction, which is direction x and also direction y. So let us try and solve this one by one. Okay, let us first try to solve this in the x direction first. So assuming the movement to the right to be positive, so the summation of forces in x direction should be equivalent to 0. So what are the forces exist in the x-axis? Okay, the first one, that is FCD. So direction dia, arrow dia ke kanan kan, so the value is positive. And then what are other forces exist in the system? FCBX, but the direction is towards the left, so you have to minus FCBX. Ada lagi tak? Tak ada. Yang lain semua in y-axis. So yang tak ada tu kita neglect. We just consider only the forces acting on that particular axis only. So the summation of this force should be equivalent to 0. Okay. Now, kalau FCD is still unknown, so saya bawa dia turun. And then FCB along the x direction can be calculated using the formula of FCB cos 60 degree. So you recall balik the previous chapter ya kalau tak tahu. And then the summation should be equivalent to 0. Tak boleh solve. There are two unknowns here. So saya tak boleh nak buat apa-apa kat sini. Okay, we further our analysis in the y direction pula. Similarly, we assume the upward direction to be positive. So summation of forces in the y direction should be equivalent to 0. So kita turunkan balik what are the forces exist in y direction. The first one is the FCB along the y direction. The arrow is pointed upward, so it is positive. And then the second force is the FCE. But notice FCE ni arrow dia pointed downwards. So kalau downwards, then the magnitude become negative. And then ada lagi tak forces acting on y direction? Tak ada. So that is all. All this summation should be equivalent to 0. Okay, now FCB along the y direction can be calculated by using the formula of FCB multiplied with sine 60 degree. Kalau tak faham, recall balik from the previous chapter. Okay, and then minus with FCE. FCE ni kita dah dapatkan from the previous equation. We already got 58.86 Newton. So you put it in your equation and this summation should be equivalent to 0. Okay, if you notice there is only one unknown over here. So you just rearrange the equation. 58.86 ni bawa ke kanan and then you divide with sine 60 and you will get a corresponding value of 67.9657. Okay, bila dah dapat this value, you can actually substitute it into the equation 1. I'm going to call this equation 1. So if I substitute FCB equals to 67.9657 into equation 1, so tinggal berapa unknown in this equation? Dan only tinggal satu unknown. Ni macam penyelesaian secara persamaan serentak lah. Okay, so can you calculate FCD? Yes, of course. You just bawa all the expression on the left to the right side and you will get a corresponding value of 33.9784 Newton. So that is how you perform equilibrium analysis on your free body diagram.